Okay, we're continuing with transformations. We're going to get a little deeper than we did in the last one here. So let's review. This is what we should have seen in the last video. What would happen if you just add 10 to the end of the function? So I've got some function here, I add 10. This would move it up. So we learned that just you can tack it on. It's totally intuitive. You add 10, your graph is going to move up 10 spots. Now, if you do it inside the function, you work where the actual variable is. This is going to move us right or left. This is going to move us horizontally. So, and this is the one that's counterintuitive. Plus moves us left. This graph would move 10 spots to the left. Okay, so here's the kind of question I like here. We've got the square root of x, and we're adding 2 to the x value. That's what this is saying. We're adding 2 to it. Okay, so our new function is going to move 2 spots to the left. So a horizontal shift to the left. Now, when we put these things together, it gets quite complicated. And there are some shifts that I wish we could avoid because they really give people trouble. But we're going to put them together. You got to do it in a certain order. So what we're going to do is we're going to do the horizontal shifts, and then we do the vertical. Okay, so we're going to move right and left first, and then we'll go vertical. Well, this is the graph. Well, let's see what they did. Yeah, that's kind of confusing. Well, let me talk you through there. So the original function is the absolute value function. It makes the v. Now, if we're working on the inside, the plus 1 moves us to the left 1, moves us back. So we have our v, it's now back 1. And then the minus 3 moves us down. So we've moved our v back 1 and down 3. Okay, so pause the video if you want to try it. So this is going to the right. We're changing on the x, so to the right 2, and then the 4 is intuitive. It's just going to move us up 4. So I'm right here. So my v, sorry, that's very imperfect. And I don't need yours to be perfect either. I just want you to see the shift. So I move 2 to the right and up 4. Okay, so this is the square root function. So this is the square root of x. All right, well, we've moved it. We've moved it 1 to the right, so that is rights are minus 1, and we've moved it up 2. So our new function, we'll call it g of x, is right 1, up 2. Okay, now I'm going to show you this one because there's something about it that people will usually miss. This one wants us to go 1 to the right. Now, you have to make the change inside the function at the value of x. So a lot of times what people will want to do is they'll say, okay, well that would be a vertical shift down. So that isn't it. It's happening at the value of x. So it's take away 1, and we're going up 1. Okay? So it has to happen inside the function right there. That is we're going 1 to the right, and then we're going up 1. And there's my new function. I don't know what we need to call it, but. All right, now we're going to flip these upside down. And so, hold on, I don't want to talk about both yet. We're going to talk about a vertical reflection. Vertical reflection is going to take this and it's going to flip it upside down, or over the x-axis is the fancy way to say that. Oh shoot, they've got both of them here. Let's just talk about vertically. So if you were shifting this upside down, all you have to do is put a minus in front. So if you were graphing something and you had x squared, negative x squared is going to take all the output values and it's going to make them all negatives instead of positives, which would turn it upside down. Hold on, I'll come back to this. I'm trying to see if, let's go here, and then I'm trying to avoid the confusing shifts here. All right, so if we want to do this vertically, what we're going to do is all we have to do is put a minus sign in front of the whole function. That will take whatever you got out of the function, it'll now make all those y values negatives, and it will flip it vertically. Okay, I don't know if I can avoid this anymore. Hold on, I'm just trying to see what they gave us here. Okay, I guess it's time to tackle this. I'd prefer this is in the next video, but so let's go back now. So here's what we have so far. If I subtract some number from the x, so let's use a real function. Let's use x squared. If I want to move this 3 to the right, I would do this inside there with the function. If I wanted to move it up, I tack it on the end, and if I wanted to turn it upside down, I just put a minus in front. Now, even if I assigned you homework on this, I probably avoided these vertical flips. So I don't know if it's in the next video, so I guess I'll just go ahead and put it here. So if we want to flip something over the y-axis horizontally, what you have to do is you have to make that change inside on the x. So instead of putting the negative on the outside, so a negative on the outside flips it upside down vertically. If you want to flip it horizontally, you'd have to put the x, the negative, right inside there with the x. Well, that's a bad example. Hold on. Let me show you. So that would flip it horizontally, it'd flip it right over the y. So that is also a bad example. Hold on. I keep picking bad ones here. So I'm going to make it negative x. Now this, because the negative is on the inside, what it's going to do is it's going to flip it over the y-axis. So this is a cube function. If I put a negative on the inside like that, it flips it over the y, like this. Okay? Well, here's one where they've done. So they've done the square root function where they did it on the inside like this, which flipped it horizontally. Okay, I don't find these table things all that easy to understand, but so here's what they're saying. If you had a function, you want to flip it like this, all the y values become negatives, that'll turn it upside down. And if you had it like this, where you take the original function, now all the input values, so it was 2, 4, 6, 8, now all the inputs have now become negative 2, negative 4, negative 6, negative 8. What you've done, it's flipped all the output values, or sorry, flipped here. It's flipped you over the y. So let me say that again. So if you want to just put negatives on the output, you're going to get all the y's. You're going to get the opposite. So you were like this, now you're going to be like this. If you flip it for the x's, anything that was over here, or anything you put in here, is now going to be a negative. You're going to get the other side of the graph. So I put in 2, but I'm getting negative 2. I put in 4, I'm getting negative 4. So it's going to take it and it's going to flip this side over here with this side. Okay, so I think our last one here. So let's take a look at one. If I put that negative on the outside, I already showed you this one. If you put the negative on the outside, it's going to turn this thing upside down. Now here's why I avoided this example earlier. Now if you put in a negative here, it's going to flip vertically or horizontally. It's going to flip it over the y-axis. But look what would happen on this one. This is the point they're trying to make. If I flipped it over this axis, if I flipped it over y, I wind up getting the same thing. So if I flip this upside down over this y, well, I still get the same exact picture that I did before. So one more time, a negative on the outside turns it upside down. A negative on the inside flips it over the y-axis, and in this particular case, that doesn't even change anything. Okay, now this can be confusing. I think it's much better with my GeoGebra activity. It becomes more intuitive, but that's my best attempt to try to explain to you what's happening and why.